Thank you. Okay, so let me just repeat all of that because I was not speaking apparently. Okay, so today we're going to be talking about rational inequalities, right? And so we spoke a little bit how how rational functions look like yesterday. And you guys notice that whenever there are any curvy looking surfaces, any curving looking functions, that is a rational function. And that actually means that it also has asymptotes. So it could possibly have a horizontal or vertical asymptote. In this case, this function has both. And so now the question is, we're going to be introducing inequalities to them. So what happens? So the question now is where is this function, the function value, greater than or equal to 0? So whenever that says that, it always means, okay, so what is greater than this line? What is above this x-axis? So anything above this x-axis is basically this whole region. This whole section of the function is above 0, above the function value, y value 0. So what's this region that is above this axis? Well, this is starting, we always want to find the x value. So it says what x value satisfy the following. So the x value is that where the function is above the x-axis is, so it's starting, we can say that there's a vertical asymptote here, so it can't go past this line. And at this value is actually, you have to be careful because if you guys look at this specific unit, so this graph is actually going by 2's. So because this graph is going by 2's, you have to look at the units that your graph is going by. So that means that this point here is actually -2. So this is going from -2, and then let's count. So this is 2, 4, 6, 8. This is 8, so then that must mean that this point here, if it's in between, this point is 7. So this is going from -2, because this is where it's possibly getting really, 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 really close to, but never touching. And then the graph is continuing, and then going up really, 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 really close to this point. And at this x value, this point is 7. But so that's everywhere that there is some sort of graphical value. But if you guys notice, there's also a little hole here. This hole is not going to be included in our x value that is greater than 0, because remember that a hole is a point that is missing. Since that point is missing, we can't include it. So what is this point value here? Now let's talk about the holes. So remember that this is going by, oh, oops, my bad. This point here is -2. I looked at it. So this point here is -2. I had a little tick mark, so I filled it in, but this part here is -2, and the actual line between in here, so this is, if this is -2, this line here is actually 3, -3. Do you guys see that? Because it's in between and it's going by 2's. So just be careful with that. Your x-axis, I took this graph out of WebWork, so WebWork sometimes goes by 2's, by 1's. It will indicate exactly what number it's going by on the x-axis. So it'll say that this point is 2, this point is 1, and so that's how you know what your function is, what your graph is going by. So if you guys look, so let's actually write this from left to right. So we're writing our interval from left to right. The x values that are where the function is greater than 0 is starting off. So the point where it starts to be greater than 0 is at this x value. So this is the leftmost x value that there is. That's at -3. So it's going from -3. Okay, so now let's look at -3. -3 starts up here. It goes down, we're going down, up. This is where we reach the hole. Since we reached the hole, this point is not included, so we're excluding -2. So we need to, when it's not included, we have to include a parentheses, union, and then now we're going to continue. So we're going to go from -2 up until, okay, now let's continue on the graph. Now we're continuing. Okay, so now it seems like we're going to get super, super, super close to the number, the x value number 7, but it's never actually going to touch it. So now that's where we close it off. That's where our end of our parentheses is. And so our function is greater than or equal to 0 from -3 to -2, break, and then from -2 to 7. And that's it. Any questions about this so far? So this is how we can identify it from the graph. But does anyone have any questions about this so far?
No, no questions.
Yes. Like each box is each box is 4 or 2.
2. You can always tell because of the value that is on the graph. So here it says that this line is 2. So then that means that each little box, each little unit is going by 2s. So if this is 2, this is 4, this is 6, 8, so on, and it keeps going like that. It's just going by 2s. So that must mean that this is -2, -4, -6, -8, and so on.
Okay. The middle one will be 1.
Yeah, and then the middle one would be 1 unit. In between would be 1 unit. That's how we got that. So this was -2, and then since this is in the middle, this is -3. And then since this is 2, 4, 6, since this line is in the middle, this is 7.
Okay. Thank you.
No problem. Okay, so now let's do the opposite. So now let's say that the function is strictly greater than 0. If the function is strictly greater than 0, that has to mean that it's any point above this line, but not on the x-axis. So if it's not on the x-axis, then we're going to exclude this little point here. That means that we're going to create a hole there. So that point is not going to be included in our x values that are strictly greater than 0. So now let's look at what that could possibly be. So it's going to be similar to what we did. So it's going to be similar to this output from before. So all our x values that are greater than 0 are going to be similar to this because it's still above this region. But now we have 2 breaks. We have a break at -2, and let's identify what this point here is. So now that we can't include this point is the value 2. So we're going to have to exclude that point from the one that we originally found. So again, it's going from all the points that are all the x values where the function is greater than 0 is at -3, and then it's continuing, break. Oh, where's this break? At -2, so we include that. Okay, now let's continue. So it's continuing at -2, so we have a union, a break, then -2 up until this value here. This value is at 2, the x value is at 2, and now we're continuing, all up until 7. So that's how we can identify which values are greater than 0, strictly greater than 0. But if you guys notice, oh, any questions before I explain what you guys need to look for? So that's generally how you can identify what part of the function is greater than 0 or strictly greater than 0. So even though this x value is part of your graph, if the question says which values satisfy that it is greater than 0, you have to exclude it if it's saying which one is strictly greater than 0, because then that doesn't satisfy it. If you include it, it's not strictly greater than 0, because at this point, at the value 2, the function is equal to 0. So that point cannot be included in this case, even though it's a part of your graph. So that's the difference between the regular graphs and the inequalities. The inequalities add a restriction to it. So the question is, where is it greater than 0, strictly greater than 0? Okay, so it seems like there are no questions so far. So generally, whenever you want to find any of these, you're technically looking for all the x values that have any kind of restrictions. So for these kind of questions, you're actually looking for where are their vertical asymptotes. So we actually looked at the vertical asymptotes. One key thing that we had to be careful of, we had to be careful of the vertical asymptotes, the holes. This was a hole, and we also had to be careful of the x-intercepts. So whenever we're looking at any kind of inequalities, those are the main things that we're looking for. So we want to look for vertical asymptotes, holes, and x-intercepts. And then from there, we can identify which region is above the graph. So let's try an example. So this one's pretty straightforward. This was still part of the syllabus. So, but whenever you're solving for inequalities, so this is kind of like a review from when we did inequalities a little on the first day. So whenever you guys have an equation, a linear equation, and you're trying to solve for inequalities, remember that you're trying to isolate the x value onto one side. And then if you want to follow the little arrow that it gives you, you can always move your x terms to the left-hand side to follow that little arrow. So you can move 4 onto the right-hand side, left-hand side. So you would subtract 4 to both sides, and then that would give you 2 minus 4x, which is negative 2x. Bring down your 5. And then, so 4's get canceled out, you get negative 11. Then you can add 5 to both sides to get the x value by itself. And then you have negative 2x is greater than or equal to negative 16. Guys, remember to bring down your inequality sign. Sometimes I noticed that some of you guys switched your inequality sign to an equal sign on your test, and it's important for you guys to keep it the same. That way you guys know exactly what direction it's pointing in. And so now you have a negative 2 over a negative 2, that's 1, so you get x. But since we're dividing by a negative, remember that our sign is going to flip. So if it was greater than or equal to, this one is less than or equal to. So this says x is less than or equal to negative 16 over negative 2, that's 8. And whenever it says less than or equal to, that means that at 8, the function is going to go anything less than this value, and that is to the left-hand side. And you can kind of see that this little L, this little less than looks like an L. So that's how you guys can remember that that is a lesson sign. And so it's actually being included, so we're filling that in. So this graph is going from negative infinity up until 8, and that's it. So this one was kind of like a review on how to solve inequalities. But now let's go to the next part. So this one didn't have
when it's less than, then we put negative infinity.
Yes.
Okay. Okay, thank you.
No problem. Okay, so actually let me just say something really quick. This is exactly the same thing as saying 8 greater than or equal to x. So these two expressions are actually the same.
Okay.
Because x can be less than or equal to 8, because that means that any value is less than or equal to 8. But this one says that 8 is greater than or equal to any x value. This is exactly the same thing as this, because if 8 is greater than or equal to any x value, that means that it's bigger than any of these other x values. That means that 8 is the biggest. And that's true. We can see that 8 is the biggest number on here. All of the other ones are smaller. So these two values are exactly the same thing. And that's why I told you, so be careful if you're following the arrow, because if your x value is on the right hand side, it doesn't mean that your graph is going to the right. You guys always have to make sure that your x value is on the left if you're following the little inequality sign for your guidance. So if you guys if you guys end up with this, what you guys can do is switch the x value and switch the sign. That's how you guys can tell if it's the same thing. So just to be careful, just keep your x value on the left hand side if you guys have trouble with that. Any other questions? All right. So now let's continue. So we're going to actually be looking at the x squared function. And so on the x squared function, so we're actually looking for, are there any holes? Are there any vertical asymptotes, x-intercepts, or anything? Okay, so now let's ask our question. So you can see the quadratic function here. And one way to check your work from the graphing calculator is by just plugging in this function and seeing where is the function greater than or equal to 0. But you guys will have to show your written work on how you guys compute them, because like I said, sometimes the graph is an approximation, but you want the exact value. So now let's look at, so if you guys did want to plug in your function, you guys can plug it in, and then you guys can identify where it's greater than or equal to 0. But so here in this graph, we know that the quadratic functions have no holes or x-intercepts. Oh, actually, I made a list of them down here. So we have to identify if they have any. So we have to identify if they have any vertical asymptotes. But as you guys can see from this graph, there are no vertical asymptotes, and you know that quadratic functions have no vertical asymptotes. They can reach any number you want. They have no holes, but they do have x-intercepts. So let's look for those. So let's look for the y-intercepts of this function. So remember that to look for the x-intercepts, all you have to do is find where it is equal to 0. So this is how we find the x-intercepts. So we have to find them. And so we're going to set this equal to 0. And to do that, now we're just going to solve this. So we can factor this equation. If we factor it, we're thinking of two numbers that multiply to give you 4, and they add up to give you -3. Two numbers that do that are -4 and 1, because -4 times 1 is -4, -4 times 1 is -3. And now we can just solve for it. So if we set both of these equal to 0, then we get that our x value is equal to 4 and our x value is equal to -1. So you guys can do this. And then from here, all you have to do, so now you guys have this function. And so these are your x-intercept points. Once you guys have determined your x-intercept points, now you're just going to plug them into your function and test them. So since they are x-intercepts and it is including 0, so you have to look at this inequality sign now. So now that it is including 0, you can include them, because at these points it can be included. At these points they are your x-intercepts, so the function value is 0. So you can include them. But now let's test anything in between. Now we're going to have to test any values that are in between, which means that pick a number that is before -1. Okay, a number that is before -1 is -2. Pick any number that's between -1 and 4. The easiest value to do is 0, because it's going from negative to positive, so that means that 0 is in between. Pick any value that is greater than 4. Okay, let's pick 5. Now all you have to do is take all these test values and just plug them into the original equation. So if you guys plug these values into the original equation, you guys are going to plug in -2 into -2 squared minus 3 times -2 minus 4. And we're going to test to see if that is greater than or equal to 0. So if we have this, if we substitute it and then just simplify everything, we're going to get that 6 is greater than or equal to 0. So is it true that 6 is greater than or equal to 0? So that's the question. And we can actually tell that it is. So you guys have this. And then now you're going to do the same thing for all these other values. So you're going to plug in 0, and then after you plug in 0 into the original equation, test it. So you would actually end up getting -4. Is -4 greater than or equal to 0? The answer is no. -4 is negative, so it's smaller than 0. So that doesn't work. So that means that this interval up here, so this interval worked, this interval did not work. And now if you plug in 5 into our function, we would actually get 6 is greater than or equal to 0, which is true. So now this function will work. So now let's actually write out the interval that our function works for. So it's going from -infinity up until -1. It doesn't include this interval because it's not greater than 0 in this interval. So it's going to jump over. So it's going to jump over this interval. The next point that it does include is at 4. So it's including 4. and then it's going up until infinity. So that's how we can get our answer. And then from this graph here, you guys can tell that that is the point where it is going from. So this part right here, so this point right here is -1, and this point right here is 6. Oh, sorry, what was it? 4. Oh, it says it on the graph either way. There's a 5 here, 4. So that's how you guys can tell. So in fact, this graph actually is greater than 0 from -1, from negative infinity to -1, and then from 4 to infinity. Questions about this? All right. So this is, again, just how you can find all of these. So if you guys want to take a look at how you find, so now let's take a look at an actual rational function. So the rational function, again, we're going to have to look for any vertical asymptotes, holes, or x-intercepts. And remember that last time I told you guys that the easiest way to identify these in a rational function is by factoring everything. So if you guys factor everything out, you guys are going to have, so you're factoring out the numerator. Factoring out the numerator, we can see that two numbers that multiply to give you 6 are 2 and 3. And then to add up to -5, both of them have to be negative. So now that we have this, all we're going to do is factor out the denominator as well. This has a GCF of x because they both have x in them, so we can factor out an x. And then that means that in the inside, we're left with x minus 5. So we have this. So just by looking at this, are there any holes? So does this function have any holes?
No.
No. And that's because nothing cancels out. So we can't cancel out any of these terms. So because of that, there are no holes. So we don't have to worry about that. Okay, now let's look for the, and so I actually started off by looking at the x-intercepts. So now let's look for the x-intercepts. Remember that to look for the x-intercepts, there's a shortcut, and you guys can remember, I pointed this out yesterday, you guys can remember that the numerator set equal to 0 tells you what the x-intercepts are. And that's because when you cross multiply over 1, the denominator is going to get canceled out because you're going to basically multiply the denominator times 0, and that's just 0. So that was a tip that I told you guys yesterday. So if you guys set the numerator equal to 0, that will tell you your x values for this. So this is how you can tell this. And if you guys need a little bit of work to be shown, then you guys can set both of these equal to 0. So you can set x minus 2 equal to 0 and x minus 3 equal to 0. And then from here, you guys can solve that your x value on this side is 2 and your x value on this side is 3. So these are our x-intercepts. Okay, we've got that. But now let's look for our vertical asymptotes. So the vertical asymptotes that we get, the vertical asymptotes now come from the denominator. Remember that the vertical asymptotes are the restrictions. What can x not be? So let's do the same thing. So on this side, since we have an x, we set both of them equal to 0. So in this case, we just have x is equal to 0. And then on this other side, we have that x minus 5 is equal to 0. And if we solve for x minus 5 equal to 0, we get that x is actually equal to 5. And now let's just keep, now we have all of our important points. These are called, so all these points here are called there are important points because we have to test out which intervals work. So let's plot them all on the number line. We're going to plot them from smallest to biggest. So we're going to go from 0, 2, 3, and 5. Now let's actually just test every point in between. So if we test every point in between, we're going to have to pick any number that is, oh, but first let me do the fill-in circles. So the x-intercepts. The question is, are the x-intercepts included? They are included only if there is a greater than or equal to sign. Since it can be equal to 0, that means that our x-intercepts are filled in. They can be included because at that point, our y is 0. At the vertical asymptotes, Vertical asymptotes, remember that's a line that the function is never going to touch, so those points are not going to be included. So that's how you guys can identify what's filled in, what's not filled in. Now let's test them. Okay, so anything before 0, we can pick -1. Anything in between 0 and 2, we can pick 1. Anything between 2 and 3, let's pick 0.5. Anything between 3 and 5, let's pick 4. Anything after 5, let's pick 6. Okay, so now let's plug everything in. If you guys plug in -1 into the original equation, into the original inequality, you guys can just plug it in. So that's just going to be plugged in. I literally just took -1 and just plugged it into everywhere I see an x. So I'm going to have -1 squared minus 5 times -1 plus 6. And then -1 squared minus 5 times -1. And then we're just going to test. So is it greater than or equal to 0? So just simplify this. We get 2 is greater than or equal to 0. And that is true. So we get that 2 is greater than 0. So we can satisfy that. So that is satisfied. And then now we're going to test each of these points. So once you guys test each of these points, we're going to have 1, plug that in, we get -1/2. Is a negative number greater than or equal to 0? No, so that does not work. Now we're going to take our x value point is 2.5, plug that in, do the evaluation, simplify it a little bit, and you guys will get that it is equal to -1/25, and then plug it into here, and then you guys get that your answer is -1/2. And so I'm actually going to show you guys a trick that you guys can do on the calculator. So I do want you guys to show your work for these, but if it does have several values like this, you guys can choose your x value that you're going to plug it in. But if you guys don't want to compute all of these, that's fine. I'm just going to ask you guys that you guys write the filled in part, the inequality, but then for this part, now we can actually use our calculator for this, and this is going to be able to tell you guys. So this is kind of like a tip. So if you guys enter in your function value, so let's actually enter in the function. So we're going to go to, so let's actually enter this. Remember, to get the fraction, you guys can hit alpha y equals, and then you guys are going to get x squared minus 5x plus 6 all over x squared minus 5x. So this is our function. We can graph it, and then when we graph that, it will give us what the function looks like. So this is what the function looks like. But anything, if we want to find out what the x values and y values are, we can go to, we're actually going to go to second table set, and then for dependent, you guys, for independent, you guys are going to click ask. So now when we go to table, oops, I forgot exactly which one it is. Give me 1 minute. It's different on this calculator, actually. Once you guys go to dependent, it should have given you the option to hit set up x values. Okay. All right, so on a regular calculator, not on the Calculate 84, you guys can hit the independent, and then independent, you guys can hit ask, and then once you guys go into your table, you guys will be able to type in, okay, what happens when x is equal to 2? Or, okay, so let's just actually just go to calculate, and then here, when you guys enter value, here's where you guys can also do it. So there's 2 different ways. So you guys can either do it on the table or on the graph. The table right now is not working, but I'll figure that out later. So on the x, so you guys can also hit second, calculate, and then hit enter when it says value. And at that value, you guys can plug in, like, let's say 2.5, and at 2.5, you guys get that it is equal to 0.04. So that's an approximation. So you guys can get this. So this is so the question is 1.1/25 strictly greater than or equal to 0? The answer is yes, because it's positive. And now you guys can do the same thing. So again, you guys can just also evaluate this normally. So if you guys plug in 4, you guys get that this is approximately equal to -1/2, which is what we have here. So -0.5, that is -1/2. And that is not greater than or equal to 0. So this part doesn't work. And then again, if you guys want to do the other one, so you guys can hit 6 and see that at 6 it is equal to 2. So that's what this y value tells you. So then 2 is greater than or equal to 0, so that interval works. So that's how you guys can do this on the calculator. But if not, again, just plug it in, just evaluate it. Same thing. That was just like a tiny shortcut. And yeah, so just be aware that if there are any holes, then that once you guys get a hole, that is going to be like a new little hole in your x. It's kind of like adding a different point, and you're just going to test anything in between there. And so now let's see what we get. So it did work between the interval between here. It worked between 2 and 3, and it worked after 5. So if we write down this interval from left to right, it's starting off from -infinity, and then this interval worked up until 0. So it's going from -infinity to 0. Okay. This area did not work, so we're going to jump over this. Okay. Now we're starting off at 2. And at 2, it's included because this is an x-intercept, and it's going up until 3. So this part is included. And then in this interval between 3 and 5, that one did not work. Remember, because it didn't work. And so we're jumping over that again. And now we're going to 5, which is not included. So we're putting a little parentheses. That doesn't really look like a parentheses. And so we're including a parentheses there. And then it's going up until infinity. So any questions on that? Yeah, so if there is a hole, again, you're just gonna plop that into your interval and then just test anything in between the hole and this. So it's just like this. It's just another entry that you guys place on your number line, and you're still testing out the values. So again, if you guys graph it out, you guys will be able to see that the part where the function is greater than or equal to 0 is actually from -infinity up until this point here, which is so it's continuing up until 0. I cut it off a bit because this region was super tiny to get. So it's going from -infinity to 0. And then at between 2 and 3, there's also a little part of the function where it is greater than 0. And then it's going from 5 to -infinity. So it started way up here, but we're looking at the x value, so that's going from 5 to infinity. All right. So if there are no other questions, then I will proceed. Okay. So now let's look at this question here. Here, if you guys notice, there is an x value on the other side of our inequality, sorry. On our other side of our inequality, we kind of know how to do it when it's greater than or equal to or less than or equal to 0. So we actually want to make sure that this side is 0. So one way that we can do that is isolate all the function values onto one side. So if we subtract x to one side, we're going to have x squared over x plus 4 minus x, and then that's going to be less than or equal to 0. But let's actually combine these just so that it's easier for us to find the x-intercepts, y-intercepts, and vertical asymptotes. So if we combine these, remember that all we're going to want to do, what color should I pick? Yeah, let's pick purple. So we're going to write this over 1. So that's how we can combine our fractions, because now that since we have a subtraction sign, we know that to combine these two fractions, we need to have the denominators be the same. And right now, this denominator is x plus 4, this denominator is 1, so we have to multiply x plus 4 to the denominators, and whatever we do to the denominator, we have to do to the numerator. So we're just multiplying x plus 4 to both numerator and denominator. And now we just can distribute this. Actually, we don't have to distribute, but we don't have to distribute in the denominator. We have to distribute in the numerator. And I will show you guys why in a minute. Actually, so we have x plus 4 times x squared minus x times x plus 4 all over x. Whoa, what did I do there? Sorry. Still early. So
Is it possible to do instead of doing x plus 4 at the top and bottom, is it possible to do x plus 4 and x minus 4? I mean, x plus 4 is already there, and then you multiply both the top and bottom with x minus 4.
So not x minus 4. You don't want to do x minus 4 because you just want to get them to be the same. So this one already has an x plus 4. Because this one already has an x plus 4, you don't have to do anything to this fraction. So all you need to do is make sure that this second fraction has the same denominator. So you guys have x plus 4. So you guys have to multiply x plus 4 to this fraction so that both of these have the same denominator. So since this one is already x plus 4, let's just multiply x plus 4 to this second fraction. That way they both have the same denominator. So we're multiplying x plus 4 to the numerator and denominator. And then from here, all we have to do is simplify this out a little bit. But now that both of these have the same denominator, we can just rewrite them both under the same denominator. How many? I know some of you guys are probably not comfortable with fractions. Let me write one extra step, just so that you guys might have x squared over x plus 4 minus x times x plus 4 all over x plus 4. So this is what we get after we actually multiply. So we would multiply x times x plus 4 all over x plus 4. Whenever you guys have the denominators that are the same, all you have to do is subtract the tops. You can subtract the tops and write them all over the same denominator. So that's what we have here. So this is the top part. So we're subtracting the top part over the same denominator. And now that we have this, all we're going to want to do is simplify the top a little bit. So we can distribute the x. So we're going to have x squared minus x squared and then minus 4x. Because if we multiply negative x times x, that's negative x squared. Negative x times 4, that is negative 4x. All over x plus 4. So that's how you guys have this. But now remember that we're looking for the x-intercepts, y-intercepts, and wholes. So we have to ask ourselves these questions. And the easiest way to identify all of these is by factoring all of this. So if we factor x squared minus 4x, can we simplify this a little bit? The answer is yes.
Yes.
Yes, because we can cancel out x squared minus 4x. So now let's just rewrite this. So we're going to have negative 4x all over x plus 4, and then we can find our wholes, x-intercepts, and everything else. All right, so now let's actually see where are our vertical asymptotes. I'm going to write that up here. So let's do our vertical asymptotes first. So we know that this is our function, and we're going to ask ourselves, okay, so if this is our function, where are the vertical asymptotes? And then remember that the vertical asymptote actually comes from just setting whatever the denominator is equal to 0. So we're going to set x plus 4 equal to 0, and then just solve for it. So we can subtract 4 to both sides. So x is equal to -4. So that's how you guys can get that. And then, so now we're also going to be looking for our x-intercepts. So in our x-intercepts, we get that for the x-intercept, what do we have to set equal to 0? In this case, we're going to set the numerator equal to 0. So we're going to set -4x equal to 0. So we have that if we divide -4 to both sides, we're going to have that our x value is equal to 0. We're only interested in the x values right now. We don't actually have to look for the y coordinate yet. Actually, no, we don't have to. And then now we're just going to look for, are there any holes? So are there any holes?
No.
No.
Hmm.
No, we don't have to worry about the holes because nothing simplifies. You can't cancel anything out. So these are the three main things that you guys have to look for whenever you guys are looking for inequalities: vertical asymptotes, intercepts, and holes. Are there any of these? Well, are they? And now let's test it. So we have to test -4 and 0. So if we do that, we're gonna make our line graph. We're gonna plot -4, we're gonna plot 0, and now let's test these points. But let's see, can we include it? So can we include -4? Is -4 included in this? Can it be -4? Can x be equal to -4? No. And that is because why? Why can it not be -4? Why can it not be -4? Does anyone know?
Because when you put -4 on the denominator, it will be 0.
Yeah, so it's a vertical asymptote, so it can't be -4. It's never going to reach it. So under your vertical asymptote, that's never going to be -4. Okay, now let's see our x-intercept. So our x-intercept is 0. So can this point be included?
Yes.
Yes. Because, why?
Because the denominator will not be 0.
Okay, yes, but it doesn't matter if the denominator is 0. How can you guys identify if it is included or not included, if the x-intercept is included or not included? What does it depend on?
Because x equals to 0.
Because the square numerator is greater than the denominator, x squared, and we have x.
Because of the less than greater sign?
Because of the less than or equal to sign. So once this,
Sorry.
that's okay. So once this little inequality has a little equal to sign, it can be equal to 0, so it can include it. So yes, so once it has this sign, once it has a little equal sign, it can be included. So now let's actually fill this in. I was using green. So we can fill this in. And now let's just test each point. So we can test them in either way. So we're going to test them by picking any number that is before -4. So we can pick like -5. Any number that is between -4 and 0, we can pick -1. Any number that is after 0, we can pick 1. So that's how you guys can generally do this. Now just plug it into your original equation, your original this thing. So we're going to have 3 little testing points. So we're going to test everything in between -infinity and this. We're going to test all of this. And we're just going to actually just fill these in. So we're just going to fill these in. So now let's plug in our x value. I'm going to erase this. Does anyone mind? I'm just going to plot it in. So now the question is -5 squared minus 5 squared equal to -5? So here's what the question is. So is it true? So what's -5 squared? Remember that we're actually plugging this in. So we have negative 5 squared, that is 25, over negative 5 plus 4, that's negative 1. And is it true that negative 25 is less than or equal to negative 5? True.
Yes.
Yes. Okay, awesome. Okay, so again, we're just going to plug these in. I'm going to actually just rewrite this just so that you guys have this. So now we're going to plug in negative 1 into this. If we plug in negative 1 into this function, then we're going to ask, so what's negative 1 squared? Negative 1 squared is 1 over negative 1 plus 4, that is 3. So is 1/3 less than or equal to negative 1?
No.
No, so this interval does not work.
Okay.
And then if we take this case, is it true that 1, so now we're just going to plug in 1. 1 squared, 1. So is it true that 1 squared is 1, 1 plus 5, 1 plus 4 is 5, less than or equal to 1? Is it true that 1/5 is less than or equal to 1?
Yeah, it's less than. Yeah, it's less than.
Yes, this is a fraction. 1/5 is a fraction. 1 is definitely bigger than 1/5. So these are the intervals that work. So now let's just graph this out. So again, we're just going to graph it out. So this is going from negative infinity. This is going from negative infinity up until 4, negative 4. And this point is not being included, so we're going to put that in parentheses. And this interval did not work, so we're going to jump over this interval. We're going to use a union sign because that's a break. It's going to continue at 0, which is included, and then it's going to continue on until infinity. So that's how you guys can graph this. So this is our solution. Any questions on how we got this? Okay. No questions? All right. Now then. Okay. So again, just to summarize, all we ever have to do whenever we're looking for this, so if there is something on the opposite side of the inequality, move that over to the other side so that this is less than or equal to or greater than or equal to or just greater than or less than 0. So make sure that this side is 0 and then look for any vertical asymptotes, holes, or x-intercepts. If it doesn't have any holes or vertical asymptotes, just look for the x-intercepts. That's usually in any polynomial. So if it's a rational function, then it has vertical asymptotes or possibly holes. But if it's just a regular like polynomial, it doesn't have those. So just look for the x-intercepts and then test your points. But if it is a rational function, you might have to look for all 3. But usually, yeah, usually it will have a vertical asymptote or x-intercept. So now you guys are going to practice these. So you guys can try them out. And then you guys can share your work and see what you guys get. So try these out. And again, this file, if you guys need to look back at it, is on Blackboard, like always. So I always post the lesson on Blackboard.
Yeah. Professor,
Yes.
can you take it? Can you take us up to the?
Here? Further up?
Yeah, more. Okay.
Okay.
So remember, all you're looking for are vertical asymptotes,
Poles.
poles, or x-intercepts. These are the things that you're looking for. And then after you find these points, then you can determine the testing points.
Can I see the questions again?
Yes.
Just for a second.
Okay. So again, do any of these have any? Do any of these have any vertical
thank
asymptotes, holes, or x-intercepts? No problem.
Professor, can we go up again?
Okay.
Maja, dobre jutro, Maja.
Professor, can we go back to the questions?
Yeah,
Sorry.
that's okay. Oops. And so once you guys have finished with these, then you guys can share your work. Oh, Galena, do you want to explain how you got your answer for number 2? Okay. Okay, that's fine. So let's go through this. So for number 2, all you have to do is again identify if you have any x-intercepts, holes, or vertical asymptotes. And so remember that all we said was that since this is a polynomial, since it's a quadratic, you don't have any horizontal asymptotes or vertical asymptotes. So you don't have to, so here she wrote that there are no vertical asymptotes or holes, which is true. And now you just have to identify the x-intercepts. So we do have x-intercepts here. What you're going to want to do is factor out, first isolate this to the left-hand side. So we're going to move 12 to the other side, and we're going to have that 2x squared plus 2x minus 12 is less than or equal to 0. And then once we do that, we can notice that each factor has a factor of 2. So we can factor out a 2 in each of these cases. And now we have 2 on the outside with x squared plus x minus 6 on the inside. And oops, I erased everything. But yeah, so once you do that, then you can continue to factor this inside part. So you guys have x plus 3 times x minus 3. And then this you have to check to see that these are your intervals that you guys get. So you guys get that x is equal to -3 and x is equal to 2. And then there's an extra. So these are your 2 points that you guys have to test. And since it's a less than or equal to sign, you guys can include them. So you guys are going to have those filled in, and then just pick any values that are in between. So pick one that's less than -3, so that's -4. Pick something that's in between, that's 0. Pick something that's after 2, that's 3. Plug it in. So plug and chug, and then bimp, 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 bimp. -4, if you plug -4 into the original equation, you guys are going to have that, or you guys can either do the original or this one, it's fine, either way. So you guys can plug that into the two equations, and then see if it is greater than or equal to 0. I don't know why it keeps erasing, but it's fine. So if you guys just plug it in, you guys should get that 28 is less than or equal to 0, okay? And then you guys just see, the main thing that you guys want to check is it true? Is 28 less than 0? The answer is no, so that's not true. And then you just want to see, okay, now what about for the other one? Is it true that -12 is less than or equal to 0? That is true. And then is 12 less than or equal to 0? That is not true. So that's how you guys can identify this. Are there any questions about this question? So this one, so yeah, you got that your answer is from -3 to 2, because this is the only part that's included. Questions about this? I just realized you guys were not able to see where I was pointing to. But I was pointing. You guys might have not seen it. Questions? Okay, so yeah, so this work is correct. All you have to do is identify your x-intercepts. So after you find out what your x-intercepts, test each point in between, and then just see if it is true that it is less than or equal to 0. You can either plug it into the original function or do as she did, and she used the simplified version where it was already on the other side. Whichever one of those work. Sometimes it's okay. Sometimes if you're not sure if you did absolutely everything correct, you can plug it into the original just to check. But they both work. They both give you the same answer. Okay. Thank you. Would anyone like to share their work for number 3? Or actually, Galina, you have number 3 up here. So do you mind if we just go over number 3 too? Okay. So for number 3, you have, so in this case, we have a rational function here. So since we have a rational function here, we have x minus 5 over x2 minus x. So this does have a vertical asymptote this time. So since it has a vertical asymptote, we want to make sure that we look for it. So you have to find out where it is. And there is a vertical asymptote at x equals 2. So at x equals 2, there is a vertical asymptote. So since remember that the vertical asymptote is an equation, so that should be x equal to 2. Oh, -2? No, 2, yeah. So x is equal to 2. And then, so since it's a vertical asymptote, it cannot be included in our point. And now let's look for the x-intercept. For the x-intercept, all you need to look for is where the numerator is equal to 0. So where the numerator is equal to 0, that is at x equals 5. So those two should be little equal signs, but that's okay. And then just test each point. So test a number before 2. She tested 1. A number between 2 and 5, that's 3. A number after 5, that's 6. Test each one. So you get that once you plug everything in, you get that -4 is greater than 0. Is that true? No. So that interval does not work. Once you plug in 3, you get 2 is greater than 0. That interval also does not work. And, oh, sorry, that interval does work because 2 is greater than 0. I was looking at the last case. And then when you plug in 6, if you plug in 6, then you guys will get that 6 gives you negative 1/4 is greater than 0, and that one does not work. So your interval, the only interval that worked here was from 2 to 5. Any questions on this? So this was the only interval that worked. Now I can annotate. So yeah, so you just plug everything in. So first you identify what your vertical asymptotes are, and then you can identify what your x-intercepts are, and then just plug them all in. Any questions? Okay. I am not getting any questions. So yeah, so that's how you can do number 3. What about number 4? Oh, it says, is it supposed to be parentheses or brackets? It is supposed to be parentheses because, that's a good question. It's supposed to be parentheses because you have that this point is not included because of this. So at the vertical asymptote, it can't be included, so that has to be an open circle. And at the x-intercept is not being included because it has to be strictly greater than 0. And remember that in the beginning I explained how if it is strictly greater than 0, it's not including 0, so it's not including this point. And if it's not including this point, then you guys need to put parentheses. So that is good. Any other questions? Okay. So whose screen is this? Ola, is this your screen? Yes.
Yes.
Right? Yes, I can see that. It's your screen. Okay. So this is for number 4. So for number 4, would you like to explain your work?
Yeah, we have a fraction minus 2, x minus 2 over x squared minus 4 minus 5 less than 0.
Mhm.
Then to find the vertical, we equate x minus 2 equals 0.
Mhm.
Then x will be equals to 2. At x equals 2, there's a vertical.
Mhm.
Then there's no O there because there's nothing to cancel.
Yes.
Then we take the denominator, we factor out
Mhm.
to find the intercept. We have the common factor from x squared minus 5 plus x minus 5. Then the factors is x plus 1 and x minus 5.
Mhm.
Then x plus 1 will be equals 0 and x minus 5 equals 0. Then x is minus 1, x equals 5.
Yes.
Then it will be minus 1 and on the line it will be minus 1 and 5.
Okay, so these are your x-intercepts. Your x-intercepts are -1 and 5.
And I tested it, minus 2, I tested minus 2, I put it, I put minus 2 up in the denominator over minus 2 square minus 4 times minus 2 minus 5. And that will be minus 4 over 7. 7, yeah, over
Yes.
7.
Okay.
Because 9 plus 8 minus 5, that is 7.
Mhm.
And that is minus 4 over 7. It's not, it's less than 0.
Yes. So
Uh,
you plugged in -2. Is that correct?
Yeah, I plug in -2,
Okay.
to get -4/7.
Mm-hmm.
Then I put 0. When I put 0, I have 0 minus 2, that is -2.
Mm-hmm.
Then is 0, 0. Then I have -5,
Mm-hmm.
minus 2 over -5. That will give me 2 over 5. Minus cancel minus.
Yes. So from the interval from -1 to 5. Ola, I see that you don't have the little 2, the interval where x could possibly be equal to 2. So you have to add that interval in.
Okay.
So you see how you for your vertical asymptote you
Oh,
found that
yes.
so you have to include all 3 points. You have to
Oh,
include your x-intercept, which is -1 and 5, and you also have to include your
yes. Okay.
your vertical asymptotes. So there
Okay.
should be another little point
Good
in
point.
between the -1 and
Okay.
5. I'm trying to write on it, but it doesn't seem to
Okay.
let me
And that will give
keep
me,
it.
that will give us 0 over 4 minus 8 minus 5. That will be that one for when it's when I tested. If I tested 2, that will give me 0 because it will be 0 over.
Oh, no. You're not testing the point value 2. You
Okay.
are testing the. So actually, let me go over that one. So it's good that you got these. So I'm just going to continue on from this so that everyone can see. So the points that we found are 2, -1, and 5. So I'm going to share my screen, and then we can continue on from here. I can't write on this, unfortunately, so I'm going to stop sharing your screen and then share my screen. So from here, you found that your x-intercepts were, so your x-intercepts
-1.
were -1, x is equal to -1, and your other x-intercept was x is equal to 5. And then your vertical asymptote, remember, oh, sorry, this was your vertical asymptote. And the other one was your x-intercept. So this was your vertical asymptote, and then your x-intercept is.
No, that's my
Because the vertical asymptote cannot be equal to 0, so that's when you solve for your. And then the x-intercept is when the numerator is equal to 0. So your x-intercept was x is equal to 2. So from here, now all you have to do is just draw your little graph, your little tables. So you have -1, you have 2, and then you have 5. So this is where you guys have to test the different points. So you already tested something before that. You tested 2, and then now you have to test something between -1 and 2. So this was the part where you didn't include, but that's okay. So now you know that you have to include this part. So let me change this to a different color. So if you guys do anything that's between -1 and 2, you can pick 0. Anything between 2 and 5, you can pick 3. Anything after 5, I think you picked 8. I can't remember exactly. And so we said that it does. So did you, Ola, was it that it worked or that it didn't work for -2? If we plugged in -2 into the original function, did it work?
Yeah, -2, it works.
Yes. Okay, that's good. So we get this. So we're just going to plug this into the original. You guys can see how I'm testing things. So if you plug this in to the plug this into the x, plug -2 into x, you guys get that it is going to be a value that is going to be negative. And so a negative is less than 0, so this interval works. And then when you plug in 0 into this, all you can look for is If you guys are plugging in 0 into the equation, all you can look for is what are the last two values that don't have any x's. That is negative 2 over 5, negative 5, which is just positive 2 over 5. So this is positive 2 over 5. And is this less than 0? The answer is no. So now you guys have to test any number that is between 2 and 5. If you guys plug in 3 into this equation, you guys get a value, which is, I'm going to let you guys do that, but you guys can pick any value.
And
That's actually going to be a negative number that comes out. So for any value that you guys pick in between 2 and 5, once you guys get your answer, it's going to, well, if you guys plug in 3, I'll do it. So 3 minus 2, that's 1 over, so you're going to have 3 squared. 3 squared minus 4 times 3 minus 5. So 3 squared, that is
Negative 1 over 8.
yes, thank you. Negative 1 over 8.
and it's not.
So it's negative. So then this one does work. And then now you guys are just going to try to plug in 8. So does anyone want to plug in 8 into their calculator?
It doesn't work.
8 doesn't work, yes. So 8 is going to be positive. So the question is this greater than 0? The answer is no. So your only intervals that work. And now let's identify. So do we include 1? Do we include negative 1? No, because it's a vertical asymptote. Do we include 5?
5.
No, we don't.
No, because it's also a vertical asymptote.
No, we don't.
Yeah. And then do we include 2?
No.
No.
No, because there is no, because our sign in this case is less than. So the only intervals that we get are from negative infinity. So we're starting from left hand side. Negative infinity up until negative 1. And then that's not included. We're going to skip over this area because this interval was not included. So we're skipping over it. And then we're continuing at 2. And then that's going up until 5. So it's going up to 5. And then that's where it stops. It stops here because the rest of the interval is not included. So this is our answer for this. Any questions? So again, this is just plugging things in, finding your answer, and that's it. So
because our denominator is greater than numerator, because we have a square, x square, which is greater than x, then we use the denominator to factor out to get our vertical.
to get your vertical asymptote, all you have to do is set the denominator, whatever the denominator is, set it equal to 0, and then see whatever points those are. That's what it cannot be. That's what it is, sorry. Because remember that the vertical asymptote comes from the domain and seeing what x values can the function not be. So the function, since it's a fraction, it cannot be 0 in the denominator. So the values that make it 0 are x equals -1 and x equals 5. Any other questions? Okay. It doesn't appear to be that I have any other questions. So that was how you guys can find inequalities. Let me just briefly say it again. So whenever you're looking for them, just look for vertical asymptotes, holes, x-intercepts, pick points, find your values, and then test any point that is in between. Check off the intervals that work, and then just write your answer. That's all you have to do. Those are the general steps. And I'll upload the video of this if you guys need to rewatch it again. But now let's talk about exponential functions. So we're going to start to talk about exponential functions now. And so exponential functions actually follow the form of something being multiplied to the outside of bx. It has this form, y is equal to c times b to the x power. This is the general form. It's kind of like how the equation of a line is y equals mx plus b. In this case, exponential functions have the form y equals c times b to the x. That's just a general function. And the c value, whatever this first term is that is multiplied to it, that's actually the y-intercept. And the base is telling you how fast the function is growing or how fast the function is decreasing. So if you guys look at different examples, oops. So like for example, here you guys have, this follows the form c times b to the x. So if you're, so I mentioned how c, there it is, okay. So I mentioned how c tells you the y-intercept. So if your y-intercept is, for example, 2, then your function is going to cross at 2. It's going to cross the y-intercept at 2. And if your b is positive, that's actually meaning that it's going to be increasing. So here you guys can see that this graph is increasing. It's getting bigger and bigger and bigger exponentially, and it's starting off at 2. It has a y-intercept at 2. And then if your b is a fraction, if you guys get to 1, that's a flat line, but once you guys get it to be a fraction, that is actually now decreasing. So anything that is between 0 and 1 is a fraction, and now that it's a fraction, that's actually going to be decreasing. So it's going to be decreasing, and then it still has a y-intercept at 2, so that's what that tells you. And so if you guys think about the function of 2 to the x power, here, even though there is nothing being multiplied to the front, like there is no c, there kind of is in a way, because anything that, whenever you don't have anything in front of that, it's kind of like there's always an invisible 1 there. So there's always an invisible 1, which means that your y-intercept is 1. And this is growing at twice the speed. So if you guys are wondering how did these people get the graphs and charts for coronavirus, that comes from exponential functions. They were saying that that this thing was growing exponentially quickly. That's where this is coming into play. So that's kind of how you guys can relate it to real life. So yeah. And then if it's growing at triple speed, then you guys can say that this is growing at 3 times that speed, so it's growing really quickly. 10 times the speed, that's going a lot quickly. So you have twice, 3 times, and then 10 times. And then for a half, same thing. So if it's decreasing, it's a half is gonna decrease a little slowly. Then if it's decreasing by 1/10, that's gonna decrease a lot more quickly. And then again, so the 3, so that just tells you the y-intercept, and then it's growing at twice the speed. And then if it's negative, if your y-intercept is negative, then that means that your graph is going to be pointing down. And since it's a fraction, it would be pointing up. So this is what the function would look like. So it's actually going to depend on the y-intercept if it's pointing up or down. So that's depending on the y-intercept, which makes sense because that's also your leading coefficient. And remember that your leading coefficient, if it's negative, it points down, and if it's positive, it points up. So that's how you guys can identify that. And then we're also going to be talking about e. E is similar to pi. E is actually a number that is 2.17 blah 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 blah. And so is pi. Pi represents 3.1415 and so on and so forth. So E is the same thing. E is an irrational number that is written in the form of a symbol. So we represent 2.171 blah 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 by E. And so that is, and then remember that anything in front of E, which is 1, an invisible 1, that is your y-intercept. And then it's growing at E times the speed. And one thing that you guys have to know is that we talked about inverses. The inverse of E is actually the ln of x. The ln of x is called a natural log, which I'm going to introduce in a minute. And so I just wanted to let you guys know that these two are inverses of each other. So since these two are inverses of each other, it's kind of like division is the inverse of multiplication, and addition is the inverse of subtraction. Those are inverses, so they cancel each other out. And then another way of representing ln of e is by calling it log, the natural log of base e to the x. I'm going to introduce that in a bit. Okay, let me actually get to that before I start to make it, before it starts to seem a little confusing. Okay, so we just went through all of this. So c represents your y-intercept, b represents your base. If it is greater than 0, if b is greater than 1, your graph is increasing. If it is a fraction between 1 and 0, then your graph is decreasing. And e represents the number 2.718281. And so here, like I told you guys, here c is 1. If you guys have this example, c is 1, so your y-intercept is 0, 1. Okay, so whenever we're given exponential functions, there has to be a way of solving for x, because you guys have never solved for x when x is, well, maybe you have. You guys, we don't really know how to solve for x when x is in the exponent. So one of the ways of solving for x whenever it's in the exponent is that, so this form here is called exponential form. And to solve for anything in the exponent, you guys can switch, one way of solving for it would be to switch it to something called logarithmic form. And so logarithmic form is actually just thinking about, okay, b to some power gives me a. That's what you basically can think of. So here, this is like saying log base b of a equal to x. So for example, here, if you guys wanted to switch over 3 to the 4th power equal to 81, you guys can say, okay, log base 3 of 81. And this basically means, so let's ignore this 4 right now. So this basically means 3 to what power gives me 81? That's in a way of what you guys can think about. Okay, and then that is equal to 4. So I'm going to just have you guys practice rewriting 2 of these examples in this form. So all you're going to do is, so right now, all you have is in this exponential form. So here, b is 3. So that's going to turn into your base. So 3 is going to turn into your base. And then whatever's on the other side, which is a, so example here, this is 81. So that's going to turn into your a here. And then whatever your exponent is, that's going to go on to the other side. So since 4 is our exponent, that's going to go on to the other side. So I'm just going to have you guys rewrite 2 of them in this form, just so that you guys get a little bit of practice on this. And then we can continue. But you guys can try these out. See, and then once you guys get this done, you guys can just write your answer in the chat. So all you have to do is rewrite. Identify your b, put it in the base, identify your a, put it right next to it. Your exponent goes on the other side. I'll give you guys about 2 minutes to do this. Okay, so I got a couple of answers for A and B. Okay. And so now let's do this. So let's do A. So for A, it is true. So here your log, so we're going to write log. In this case, our B is the base. So our base is 2. So log base 2 of whatever is on the other side. On the other side, we have 256. So log base 2 of 256 equals 2. And then whatever the exponent is, that's 8. So we have this. So yes, that is true. And then for B, you guys had, so we have log. In this case, our base is 3. So we're going to have log base 3 of whatever's on the other side, which is 12. So that's log base 3 of 12 equal to x. So yeah, so that's how you guys can do that. And I see that some of you guys did get that. So that's awesome. And then, okay, so whenever you guys are thinking about this, one way of thinking about this is by saying, so like I told you earlier, so sometimes this x won't be here. And so it'll say evaluate log base 2 of 16. Oops. It'll say log base 2 of 16. One way of thinking about this is, okay, 2 to what exponent gives me 16? If you guys are good with multiplication, you guys can identify that 2 to the 4th power. Let me just keep erasing. So you guys, if you guys are good at this, you guys can say that 2 to the 4th power is equal to 16. So this is just equal to 4. So you guys can identify it like that. But another way of doing it, which shows a little bit more steps, is by basically changing the exponential form back into logarithmic form. Sorry, changing the logarithmic form back into exponential form. So you're going to turn 2 to some exponent is equal to 16. And then you guys can rewrite 16. So 16 is rewritten as 2 to the 4th power, which means that your x value, for these two to be the same, your x has to be 4. So that's how you guys can get that. And so that's basically how you guys can get that. Any questions on that? So you can just set this equal to x. Say 2 to what exponent gives me 16? So 2 to the 4th power gives me 16, so x has to be equal to 4.
Yeah, Professor. Professor.
Yes.
If you have a logarithm to the base of a number like log 2 to the base of 2, is it the same thing as 1?
I'm sorry, repeat that one more time.
Yeah, if you have a log 2 to the base of 2.
Log base 2,
Log 2 to a number of 2 when you have a 2 also. Yeah.
Oh yes, this is 1, yes.
Okay.
Yes. So log base 2 of 2 is equal to 1. That's because 2 to what power gives me 2? That is equal to 1.
Okay.
So yeah. So 2 to the 1st power is 2, so that's correct. That's another way of thinking about this. So here, again, it's the same thing. So if you guys wanted to find log base 5 of 125, again, it's like thinking 5 to what power gives me 125? And that's just by rewriting it like this. So you're taking the logarithmic function and then rewriting it back into the exponential function. So you guys get that 5 to what power gives me 125? Well, that is to the 3rd power. But if you guys are not comfortable with thinking about it, you guys can also rewrite this as 5 to the x power is equal to, and we can rewrite 125 to have the same base. If you guys write this on your calculator, you guys can say 5 to the 3rd power. And then now that they have the same base, all you have to look for is look at the exponents. So once you have the same bases, the exponents are equal to each other. This is from algebra. And so since they're equal to each other, x has to be 5. X has to be 3. So that's how you guys can get that. Any questions about this?
No.
All right. Okay, so here are some things to know. Whenever you guys have, sometimes there is no base. Sometimes you guys just have log of x. But if there is no base, it's similar to if x, so it's kind of like how there is a coefficient in front of x. The invisible coefficient in front of x is 1. Here in log, if you guys have no base, the invisible base is 10. So since the base is, so whenever you guys see log of x, that actually means log base 10 of x. So they just don't want to write it out just because that's kind of like the general notation. And then again, if we have log base b of b to the x power, that's just again thinking of b to some exponent is equal to b to the x. So if you have this, if you guys have it in this form, this is exactly the same thing as just taking, oh, okay, so then it must be the exponent, because b to some exponent is equal to b to the x, and that's just, it has to be the same exponent, so it has to be x. That might have seemed a little confusing, sounded a little confusing, but generally, okay, this is all you have to think about. They have the same base, so the answer is just the exponent. That's the simple way. And then for number 3, here, whatever your base is, so this is log base b of 1. So now you have to think of b, any base raised to some exponent gives me 1. The only exponent that you can raise anything to, so like for example, if you raise 2 to the 0 power, this is equal to 1. If you raise 3 to the 0 power, this is 1. If you raise 10 to the 0 power, this is 1. So it can be any base raised to the power of 0 gives you 1. So log base b of 1 is always 0. And then there's also something called the natural log. This is what I spoke about earlier. The natural log is actually the same thing as log base e of x. So e is the irrational number 2.17. So this is the general form. So instead of writing log base e of x, they call it something called the natural log, and that's what this is here. And let's actually do an example then. So we spoke about the inside being 1, but let's look at an exercise where the inside is 0. So now it's kind of like thinking, okay, 10 to what power gives me 0? Is there any exponent that I can raise 10 to that gives me 0 in general or any case? There is no x value. There is no exponent that can turn 10 into 0. That just isn't something that algebra does. There's nothing that can be multiplied to itself to turn 10 to go back into 0. So that does not exist. So inside the parentheses, it cannot be equal to 0, and it can also not be negative. So that's coming from the graph. So if you guys look at log, the graph of log is all of the positive values. So you guys can see that the inside has to be all positives. So it's kind of like similar to the square root function. It can't be negative. But the only difference is that in log, it's similar to how we find the domain for the square root function, because we have to look for where the inside is greater than or equal to 0 in the radical, in the square root. But in this case, it also cannot be equal to 0. So if we wanted to look for, oh, I was about to start to get into talking about domains, but let me save that for a little later. Okay, so now let's do a couple of examples. So we said that E and ln are inverses of each other. What that means is that they actually cancel each other out. So whenever you guys see ln and e, that just cancels each other out, and this is just equal to 4. And for whenever you guys have, I didn't do an example where you guys have a fraction. So you guys can say that this is equal to log. So log base 2 of 1.25 is the same thing as log base 2 of 1/4. And that is from the information about fractions. 0.25 is the same thing as 1/4. If you guys aren't too sure, you guys can plug it into your calculator if you feel comfortable with that. you guys can plug in 0.25, hit math, hit fraction, hit enter, enter, and that's 1/4. So that's how you guys can find that out. And then, so now you guys have to think of, so this is the same thing. So you're gonna wanna set this equal to x if you wanna do it algebraically. So 2 raised to some power, whatever's on the other side, x, is equal to 1/4. So this is what you're thinking about. So 2 raised to some power is equal to 1/4. And now we want to find out what this is. If we're trying to find out what this is, we want to rewrite them to have the same base. So if we want to rewrite these to have the same base, we're going to have 2 to the x power is equal to, how can we rewrite 2 to have the same base as 2? So 4, we can make
negative power.
Yeah. So we can rewrite 1 over 2 to the second power. 2 to the second power is the same thing as 4. So we have this, but since it's in the denominator, what we're going to do is move it over to the numerator to have them be the same thing. And whenever we switch them from the denominator to numerator, we're going to have the exponent be negative. So that's what happens. So now here we have that x is equal to -2. So this is actually equal to -2. So that's how we can get that. Any questions about this?
I mean, when we have a log to log any number to a decimal point,
You can just turn it back into a fraction.
we take it to fraction. Okay.
Yeah.
Okay. Okay.
Yes. Turn it to a fraction and then see if you can get the numbers to be exactly the same. So whatever this base is, you want to turn this side to have the same base. So you just go through the algebra properties. So you know that 2 to the second power is 4. So that means that we can rewrite 4 into 2 to the second power. And then since this is in the numerator, we want to switch this to the top. But when we do that, that means that the 2 becomes negative. Because remember that if we switch a term with an exponent to a different side, the sign changes. That's from algebra 2. And so that must mean that x has to be equal to -2. So if you guys do not have any other questions, you guys can try these 3 practice problems to try to see if you guys know. So again, this is just thinking 7 to what power gives you 49. So you guys can identify this, identify this, identify this. And then we can talk about domain. So this should actually say evaluate. So you guys are evaluating these. So you guys are evaluating these, and then you guys can use this change. So if you guys need to, you guys can just set this equal to x and then rewrite it in this form. So rewrite it from logarithmic form back to exponential form. So I'll just give you guys another minute. Okay. So let's see. So again, for this, all you have to think of is 7 to what power gives us 49. You guys should know that 7 to the second power is 49. So that's one way that you guys can do this. And then if you guys are not really too sure, you guys can always just rewrite this and say that, okay, this is equal to something. I don't know what it is yet, but I can rewrite it using this changing property. So I'm going to change b. So my base in this case is 7 raised to some exponent, whatever's on the other side, is equal to 49. So then from here, you guys can rewrite that 7x is equal to 7 to the second power. And then that's how you guys can identify that x is equal to 2. So that's how you guys can generally do this. For log of 100, that log base, so here, remember that since there is no base, there is an invisible 10 here. So 10 to what power gives us 1,000? That is 3. So that's how you guys can get that. For this third one, you guys are basically thinking about, okay, so 6, let me rewrite this actually. So you guys are taking this, and you guys are saying, okay, something, so log base 6 of 1 over 36 is equal to something. That means that 6 raised to some exponent is equal to 1 over 36. And then from here, you guys can just try to make both of these have the same base. So we have 6x is equal to 1 over 36. We can rewrite 36 to be 6 to the second power. And then again, if we want to rewrite this to be in the same place, we have to move this up. So this is going to be 6 to the x power is equal to 6 to the negative second power. Because if we switch it from place to place, if we switch it from the numerator to denominator or denominator to numerator, it becomes a negative. So now our x value is just that x is equal to negative 2. So x is equal to negative 2. And the reason why that is because if you want to say that these things are equal to each other, then their exponents have to be equal to each other. So that's how you guys can get that. And that is what I did see on some of yours in the chat. You guys did have that out, so that is good. Any questions about this so far, though? Any questions? I did see that a lot of you guys got that, so that's good. Okay, now let's talk about the domains of these functions. So the domain of these functions is similar to the square root, but the only difference is that it cannot be negative and it cannot be 0. So, or 0. So it cannot be negative or 0. So those are the two things. So here you guys have to set whatever's on the inside of log greater than 0. So here in this function, the domain for log of x is just where x is greater than 0. So that's just from 0 to infinity. We're not including 0 because it cannot be 0. For log of 3 log base 7 of 2x plus 8, if we're trying to find the domain, we don't even care about anything on the outside. So don't even worry about that. All you're looking at is what is inside of the log function. Anything inside the log function, that has to be greater than 0. So we're just going to set this inside part greater than 0. This is only when you're identifying domain. So when you're identifying the domain, all you have to look for is the inside, set it greater than 0. And then if we solve, we subtract 8 to both sides. We get 2x over negative 8, divide by 2. We get that x is greater than negative 4. So now here, if you guys graph this out, you guys are going from negative 4, and this is anything greater than negative 4. So this is going from 4, negative 4, not included, up until infinity. So it just keeps going. So that's the domain for that one. For ln, you can also do the same thing. So for ln, it's the same thing as the log. Remember that ln just represents log base e. That's from up here. It's just log base e, just written differently. And so it's exactly the same thing. All you're going to do is take whatever's inside your log function, which in this case is x minus 1, and then just set that greater than 0. You don't have to worry about this 3 on the outside. You don't have to worry about that. So you just set this greater than 0, and then you solve for x. So you have to add 1 to both sides, and you get that x is greater than 1. If x is greater than 1, then you guys have your 1. It is not included, and it is going to the right. So your interval, your domain and interval notation is from 1 to infinity. And that is it. Questions about this?
Professor,
Yes.
that means anytime we are looking for the domain, we always use sign of greater than.
Yes, always greater than. So you always have to set whatever's inside greater than 0, and then solve for x.
Okay. And like the one we have that x is greater than minus 4, that greater, does it change to the less than?
Oh, okay. So it only changes to the less than. That's a good question. It only changes to the less than if you have a negative in front of coefficient. So remember how if there is a negative sign, so if we were, I'm going to use a different color. If we had a negative 2x in front of here, then we would have to divide by negative 2, and that would mean that our sign flips.
Okay.
So that's when it would flip. So if we're dividing by a negative number, that's when it would flip.
Okay.
So it follows the same rules. It's the same thing as if we were solving for the domain of the square root function, except in this case, it's only strictly greater than, no equal to.
Okay.
Any other questions?
Thank you.
No
So
problem.
what's the purpose of the outer numbers? Is it for a later lesson?
That's for a later lesson, yes.
Okay.
Yeah, I'm gonna teach you guys that after the test, after this exam. So that would be on Monday's lesson.
We have a lot of things to digest.
Yeah, so I'm not gonna include that. I don't want to include that in the next one either. I'm gonna save that until after. But any questions on this? So these two were not too bad. It's just evaluating. So you guys just have to be comfortable with evaluating and finding the domain. So those are two topics that are also going to be included on the test. But you guys can practice some of these. So practice finding the domain. So just state the domain of these functions, and then this one's the one that you guys are going to have to think about a little bit. But these two are pretty straightforward. I want you guys to think about these one and see what you guys get for the domain. So think about what the absolute value does to a value, and then let me know what you guys get. So just think about it a little bit.
Mhm.
Oops. And so if you guys were able to identify what the domains for these functions are, I would like you guys to, is someone sharing their screen? Yeah. Ola, you're sharing your screen right now. Was that intentional or was that by accident? If it was by accident, I can remove it. Ola, I'm gonna stop sharing it just because I think it might have been a mistake. Oh, okay, it's back. Ola, are you trying to share your screen?
No, the screen changes to something else. That's why I was.
Okay, so I took it off.
Okay, I've stopped the sharing, and I only heard your voice. I didn't hear anything again.
Oh yeah, there was background noise, so I muted some people.
Okay.
Yeah.
Okay.
But okay, so I'm assuming that some of you guys did already find your answers, so that's great. So I'll go through some of these. So for this one, so again, all you have to do, remember, I'm gonna do one of them and then just talk about I have time to do all of them. So for this one, all you're gonna do is again, so we're just gonna take the inside. So for the domain, just take the inside and set it greater than 0. So we're gonna take x plus 4 greater than 0. So our domain is where x is greater than -4. So our domain is basically at -4, and then that's not being included, that's going off until infinity. So that's from -4 to infinity. And then for the second one, we have that x plus 5 has to be greater than 0. So x has to be greater than -5, which is going from -5 to infinity. So that's how you guys can get that. So these are your two domains. And so the question was, what happens to this in this domain? So I see some of you guys wrote that there are different domains. Would the domain ever have brackets in it? It depends on the question. There might be, I mean, if you're doing compositions, for now I'm gonna say no. In the examples that I've shown you for log so far, there aren't cases where you will have a bracket around log because it's not going to be including this it's not going to be including this point, so it will always be a parentheses around the domain. So that for now the answer is you will always have parentheses around the domain because it's not including the point. So that was one of the questions that I saw in the chat. Okay, so now let's talk about the interval. So now let's talk about the domain for this. So for the absolute value, you guys have that the absolute value turns everything positive. So I know some of you guys wrote that your interval for the third one was from -infinity to infinity, and others from -infinity to 0, and then from 0 to infinity. So those are all good questions. Those are all good answers. And so that's actually true. Yeah, so you guys were able to identify that this is actually since the absolute value takes care of the negatives. That means that I can plug in any x value to be negative. So for example, if I plug in log of the absolute value of -3, that means that, so I can let my x be negative, because then this is just going to turn it into log of the absolute value of 3. And that makes it true. So then that means that I can possibly find an answer to that. So that means that all of my numbers work. So every number can work. All my positives and negative numbers can work. But the only question is, does 0 work? So remember that it cannot be 0. So your domain for this question is going from -infinity to 0, and then from 0 to infinity. So this is your domain for this question. And so usually it would be anything greater than 0, but because the absolute value takes care of our negatives, it can also now include our negative numbers. So that includes everything except 0. Questions about this?
Professor,
Yes.
supposing we have log absolute x minus 1 absolute, that is x that is inside, maybe you have x minus 1 inside the absolute, or x plus 1,
Yes.
or any other thing. If
Yes.
we have, if you have a x minus 1 or something like that, then how would that one work? Is it going to have the same minus infinity, comma 0 union 0 infinity?
So for this, so again, this is kind of like the same thing. Okay, another way that you guys can think about this is this goes back to to absolute value inequalities. So you would have to set x minus 1 greater than 0. Greater than 0. And so that's where this comes in. So before, in this example, you guys could have solved the absolute value of x greater than 0, and that would have given you this. In this example, you can set the absolute value of x minus 1 greater than 0, and then that's how you will get your answer. And so we actually learned about this on the first day, so you guys should be familiar with this.
Okay.
Yes. So remember, you just have to set up your two cases, and then you can solve for it there. Any other questions? So we're almost out of class time, and you guys know how to do this. But does anyone have any other questions that you guys want to talk about?
Professor,
Yes.
for the exam coming up, it's always a short time, that we have always a short time. Maybe the question should not be many, because the other time it was many, and the time is not enough.
So in this coming exam, I am going to make it 10 to 12 questions. I don't want to make it under 10 questions because your final is going to have 10 questions. It's not going to have anything less than 10 questions, and that's not a final that I make. So I don't want to make something that's not, I don't want you guys to have, I don't want to give you guys 7 questions. You guys get used to 7 questions, and then on the final, you guys run out of time. But on the final, you guys will also have 2 hours to take the exam. So that is the reason why I'm doing that. So it will be either 10 to 12 questions. I will try to keep it in that range. Again, like I said, I'm still modifying some questions, so I don't exactly know exactly how many questions I'm going to put, but it will be 10 to 12 this time.
Thank you.
No more than that. Yeah, no problem.
Yeah, it's better when you have like 10 questions, because like we ran out of time at the end. It's hard for us to finish it.
Some people ran out of time, some people didn't. The only reason why I had 13 last time was because I had some multiple choice on it. So I figured that wouldn't really take too long, but I guess it still did take some people a little longer. So I will try to minimize that.
Is it the same thing? We have until 6 a.m. is the last time we could take it.
Yes, but try to take it earlier, guys.
I have work on Sunday, that's why.
Oh, okay. Yeah, so that's fine. Yes, you guys can. So the last time that you guys can take the exam is at 6 a.m. on Monday. But again, if you guys can do it earlier, definitely take the exam earlier. And it opens up 12, it opens up midnight Saturday, and then you guys have all day Sunday, and then the very last time you guys can take it is at 6 a.m. on Monday before class. And again, no problem. And again, just submit your written work. So in the last exam, I had some people who simply wrote down the answers that they put into web work. And that's not what I mean by written work. Written work means you have to show your actual writing of how you got the answer to web work, because I can see the answers that you guys put into web work. What I want to know is how you guys got that answer. So I grade the points that I assign to each one of your problems is from the work that you guys write. If I can see that there is some sort of discrepancy between those two, then that means that something is wrong. But so you guys, and then I also give you guys feedback. So when I give the exams back, you guys can see the feedback that I write on your exams by clicking on the attachment option that I see that you guys have on your exam. And then you guys can do that. For the multiple choice questions, you guys didn't have to show work for that. If you guys got it right, you guys got it right. For the multiple choice, I only had them worth 1 point. So if you got it right, you got it right. If you got it wrong, sadly, you got it wrong. But that was how I graded those. I will get the last couple. I'm like almost done. I have like a tiny few people left. I will get those back to you by today, probably by before 3. So I will get those back to you before 3. Definitely go to tutoring, guys. If you guys got anything under a 70 or under from the last exam, you guys need to go to tutoring. Try to get to tutoring and practice anything that you guys feel uncomfortable with. Ask any questions that you guys need. If you guys need to email me, email me. If you guys need to if you guys want to set up an appointment where I answer your questions, that is fine. Just email me. Let me know when you guys want to do that. And just let me know if you guys need help. I am here to help. So yeah. Any other questions? There are some questions.